In this video, we'll show you how to run panel ARDL in Stata. So panel ARDL is a cross-sectional model in Stata, a methodology that is possible to be run in Stata that has three main indicators to estimate pole mean group, and dynamic fixed effect. At the first time you are watching one of my videos, do not hesitate to subscribe and activate the notification bell in order not to lose the next videos, and let me thumbs up. It will be a pleasure to know that all the four makes helping you improve your level in statistical model for social sciences. So ARDL model is methodology that can be run using panel data. So in panel ARDL model, the first step that's not compulsory is to run co-integration test. In co-integration test, I'm going to show you the three main co-integration tests used in Stata. Let us go in statistics, longitudinal panel data, co-integrate data, test for co-integration. So when I go in test for co-integration, we see that in Stata there are three main co-integration tests that are cow, Pedroni, and Westerlund. So the only test that can be run on non-balanced panel like what we are going to use here is the cow test. We have a non-balanced balance containing data in macroeconomic indicator like foreign direct investment, export, GDP, gross fixed capital formation, import, openness, economic openness, inflation, and so on. So we'll use this data set in order to show you how to implement three main indicator of panel ARDL. So the first step to run the panel ARDL model is to install the package XTPMG. So XTPMG is the package that is used in order to run a panel ARDL model. You need to just use the command ssc install XTPMG replace is that is there is already a XTPMG package installed in Stata. It will be replaced by the most up-to-date version of the package. So I already installed XTPMG in my Stata, so I will not do so. But if you have never installed a XTPMG in Stata, you just need to run this command in order to install a XTPMG. That is the first thing to do. So the second step is to set our data to be panel data. So I will tap here in command xtset. My individual variable is id and my here variable is here, that one. So I'll click on OK, and you can see that my panel has been generated and time variable run from 1990 to 2018. Data has been set as panel data. So to run our co-integration test, especially cow ones, we use the command xt test for co-integration test, followed by the name of the test that we are going to run. It is cow test, and name of variable that we are going to test for co-integration. So for this example, I'm going to test the co-integration among GDP in current US dollar as an foreign direct investment and economic openness. So that three variable we are going to test for co-integration. Then we can select the command and run, and we can see that the result of our cow test for co-integration is now available. There are some statistics that are missing for modified decay Fuller statistic and augmented decay Fuller statistics. So we just have a statistic for adjusted modified decay Fuller test and adjusted decay Fuller test, and here we have p-value that less than 5% for augmented decay Fuller, augmented modified decay Fuller, and adjusted decay Fuller is a little bit more than 5%. So we can the null hypothesis in co-integration test is in cow co-integration test is that there is no co-integration. So using, for example, the adjusted modified decay Fuller test, we can reject that null hypothesis, meaning that there is a co-integration among our variable. But it's compulsory because in panel ARDL model, whatever is pole mean group, or dynamic fixed effect, the method estimation taking consideration the long run and the short run equation. The co-integration test is not compulsory. After that, run the first estimator of panel ARDL, which is the pole mean group. So I said earlier that we have three main indicator for panel ARDL. We have pole mean group, we have dynamic fixed effect that similar to what we have like fixed effect in simple panel data analysis. So we have pole mean group that is close to pole regression in panel data analysis. So we'll run our pole mean group. You just use the command xtpmg. So we have the command xtpmg followed by different variable that are GDP, foreign direct investment, and economic openness. You see it by the d dot, first difference of our different variable in our pole mean group. we use different for this or our variable, and the comma, after the comma we specify the long run equation that just give the relationship in level, not in difference, among GDP, foreign direct investment. Let us notice that the first condition in panel ARDL is that our variable need to be stationary or first difference stationary. We have both order of co-integration in our variable. We can use ARDL, or we can also run ARDL when we have all variables that are integrated of order 1. So here is a specification of our long run equation. LR parentheses, we have the list of variables that are for this example: GDP in current US dollar. We have foreign direct investment and openness for our panel. So replace PMG. So PMG is the indicator, the pole mean group. So we just select, highlight our command and then run. We can take a little bit of time to converge after 0, 1, 2, 3, 4 iteration. So after 4 iteration, we have the result of our pole mean group indicator. Our pole mean indicator is estimated here, and you can see that foreign direct investment have a long run negative impact on GDP, while openness, economic openness, have a positive long run effect on the GDP. So all coefficients are significant for short run relationship. Foreign direct investment openness is significant at the short run, so the error correction term is significant but not negative as expected. You can also run mean group estimator. The only difference in the mean group is the reserved word MG instead of PMG. So we select our command for MG, and we can see that there is a error message saying that maximum number of iterations exceed, meaning that our mean group estimator cannot converge. So we'll try the dynamic fixed effects estimator. We have our dynamic fixed effects, so we'll just replace a name of estimator by DFE for dynamic fixed effects, then click on run, and our dynamic fixed effect model has been run, and you can see that in the long run relation, that is the relation that is up here. Foreign direct investment is can be significant only at 10% level because the p-value is 0.007. So 7% negative, and openness have rather negative impact on the GDP, but the effect is not significant. The short run, we have not significant effect at 5% level, only the error correction term that is significant. We have economic openness that can be significant at 10% and have a negative short run effect on the GDP. Another thing that we can do is to run a Hausman test as in a simple panel to see what is the better model among mean group or dynamic fixed effect. So we notice that our mean group indicator does not converge, so we'll test among pole mean group and dynamic fixed effects. So we'll use the Hausman test for dynamic fixed effect. Notice that for dynamic fixed effect we need to use capital letter because it's very sensitive. In the programming in Stata, the reserved word that we use were in capital letter, so if you don't put it in capital it will not run. So dynamic fixed Hausman dynamic fixed effect, the pole mean group sigma more is the option here. So we select our Hausman test and then run. So the p-value of our Hausman test is more than 5%. So here the consistent, our model that is supposed to be the good model here is a dynamic fixed effect. So we reject the null hypothesis, meaning that coefficient that is consistent on the null hypothesis is coefficient of the dynamic fixed effect, and we just accept this consistency of our dynamic fixed effect. We'll use the dynamic fixed effect in our interpretation as well. We can generate a log of GDP, run a model with dependent variable in log, can run our pole mean group indicator with log GDP as dependent variable as previously. In the long run, we can see that according to this model with log, GDP, foreign direct investment also have negative impact. Openness is not significant at 5%, but at 10%, no significant at the short run. More our coefficient, and we can also see if whether or not the mean group will converge in this case. It's the same problem in valid new variable name. So it's the same problem that previously we can estimate our dynamic fixed effect. You can see that in the long run, in the short run there is no significant. In the long run, you can see that according to our dynamic fixed effect, the openness is have a negative effect in the short run on the GDP, but the effect on the long run is positive but not significant. So not significant. and we can also look at Houseman test as we did previously. Put the end to this tutorial for now, and we hope it has been very helpful for you to understand how to estimate a panel ARDL using the three main indicators that are pole mean group, and dynamic fixed effect. And if you have not done yet, do subscribe and activate the notification bell in order not to lose the next video, and let me a thumbs up to help me, to encourage me produce more video to help you improve your skills in statistical model for social sciences.